force, limiting frictional force is equals to resistance force small f. Force normally is equals to mass times acceleration. Mass times acceleration due to gravity sine theta minus force, limiting frictional force, is equals to mass times acceleration. Mass times acceleration due to gravity sine theta minus coefficient of friction times normal reaction is equals to ma. If we substitute limiting frictional force with mu r, since mg sine theta minus mu mg cos theta is equals to ma, after maybe we have substituted for r normal reaction on an inclined plane, then we have that 10 times 9.8 sine 30 minus 0.5 times 10 times 9.8 cos 30, which give us 10a. 49 minus 42.4 is equals to 10a. 6.6 is equals to 10a. Then to get a, we make a the subject of the formula, which we have 6.6 over 10, which will give us 0.66 meters per second square. Resolving the force of the body being pulled up the inclined plane, the limited frictional force capital F will have the same direction with the frictional force small f. The body has the mass of 10 kg lying on an inclined plane of 30 degrees centigrade. The force acting horizontally to the inclined plane is mg sin theta, while the force acting perpendicular or vertically on the inclined plane is mg cos theta, which is also the reaction. Then the reaction to the plane will now become mg sin theta, while the weight still remains mg. We are also given that the mu is still 0.5. To stop the force, it requires that we stop the body by adding force F. Force, limiting frictional force capital F plus frictional force small f will now be equal to mg sin theta, that is the reaction. Then making the limited frictional force the subject of the formula, we now have that mg sin theta minus small f, that is the resistance force. Then the force or limited frictional force capital F will now become mass times acceleration due to gravity sin theta minus coefficient of friction mu times mass times force of gravity cos theta. Then we have that force F, your limiting frictional force capital F, is now equal to 49 minus 42.4, which will now give us F is equal to 6.6 Newton. If the body is moving up the plane, frictional force reverses in opposite direction or down the plane. That means looking at the body having a mass of 10 kg moving up the plane at an inclined plane of 30 degrees centigrade, the frictional force will now be in opposite direction, while the force acting at the horizontally the plane will now become mg sin theta. Then the force or the reaction on the plane that is giving the mass of 10 kg on the inclined plane will be mg cos theta. Then the mass of the body will still, or the weight of the body will now be mg. Now, limited frictional force is equal to mg sin theta plus resisting force. The mg sin theta plus mu, that is coefficient of friction, times mass times gravity cos theta, which is equal to 49 plus 42.4, which will give us 91.4 Newton. Example 11. A parcel of mass 10 kg rests on a lorry. When the lorry is accelerating at 1.5 meters per second squared, the parcel is just at the point of sliding backwards. What is the coefficient of friction between the parcel and the lorry? Take gravitational constant equals to 10 meters per second squared. Solution. Mass we are given to be 10 kg. Acceleration we have been given to be 1.5 meters per second squared. We are asked to find mu, which is the coefficient of friction. Looking at the diagram, you see that the body is 10 kg resting at a plane surface, which is now trying to be dragged back by a less resistance force that will make it to slide back. Then the normal reaction to it is 10, that is mass of the body times acceleration due to gravity. But we know fully well that limiting frictional force is equal to the resultant force. Then substituting force, which is ma, mass times acceleration, we now get that 10 times 9.8, which is acceleration due to gravity, which we now get 98. At the point of sliding, the limiting frictional force is equal to the frictional force. Substituting the force, the limited frictional force with a mu r, which is, we get force equals to mu r. But force is also mass times acceleration. Then we now substitute the limiting frictional force with ma. We now have ma is equal to mu r. We have not changed anything. Then we now say that 10 mass of the body times acceleration, which is we have been given to be 1.5, is equals to mu, which we are looking for, times the 98, which is the reaction of the force we have already gotten. Then we are now looking for the mu. We make mu the subject of the formula. Then what we get is 10 kg times 1.8 meters per second squared all over 98 meters per second squared. We now get 0.15. Example 12. A horizontal force of 2000 Newton is pulling a block of mass 150 kg over a horizontal surface. The angle of friction is 20 degrees. Find the acceleration of the block. Looking at the diagram, we are told that a limiting frictional force, capital F, is 2000 Newton pulling a body of mass 150 kg. And the frictional force is at an angle of 30 degrees, that is the small f. Then we are also having the reaction that is pulling the body down on the horizontal surface, which is reaction of 150 times 9.8 acceleration due to gravity, which will give us 1470 Newton. Solution. Angle of friction we are given to be 20 degrees. To get mu, we see that tan theta is equals to mu. Therefore, tan 20 is equals to mu, which will now give us 0.36. Limiting frictional force minus resistance force will give us ma. The force, because limited frictional force is resisted by the opposing frictional force, which is the small f. If we minus it, we now get the real force we are looking for. Then we now get, if we substitute the frictional